Well, we have finally made it to the end of chapter 19. Take a minute and celebrate. The longest, most difficult chapter in the book, you're on the last section here. And we're going to end by doing a summary of cardiac output. So we've had a lot of information about cardiac output. What we're going to do here is take all that information and put it together into an organized chart. So remember, cardiac output is heart rate times stroke volume. And it's the amount of blood a ventricle pumps into an artery per minute. So on average, it is 5.25 liters of blood that each ventricle, remember the right and the left have their own cardiac output, pumps into an artery. So that would be the pulmonary trunk for the right and the aorta for the left per minute. And we had a lot of things that alter it. So cardiac output can go up or down. That 5.25 is an average healthy adult at rest. It's not always 5.25. It varies. So we have factors that alter cardiac output. And since cardiac output is heart rate times stroke volume, you alter it by changing the heart rate and or the stroke volume. So really our chart is going to be about things that can affect heart rate and things that can affect stroke volume. So we're going to have cardiac output here at the top. And we'll use two colors here. We'll use a color for things that increase cardiac output and a color for things that decrease. So anything I put in orange is going to be something that will end up increasing cardiac output. Anything I put in blue will be something that will end up decreasing cardiac output. We know that we have heart rate. So on this side, we're going to put heart rate, which remember is controlled by your nodes. It's that cycle of the sodium and the calcium and the potassium. And we know that we have stroke volume, which is controlled by the muscle. It's about how many cross bridges you form. Now we can see with heart rate, remember this is going to be controlled by chronotropic agents. And we can split those into positive or negative. So a positive chronotropic agent is something that will increase cardiac output. Positive chronotropic agents are going to be norepinephrine, because remember it binds to beta receptors, activates cAMP, opens calcium gates. Where calcium comes in, you go from -40 to 0 faster. It's also going to be things that enhance norepinephrine. This would be the thyroid hormone that gives you more beta receptors. So it'd be caffeine that makes the cAMP stay active. It would be nicotine and cocaine because they make you have more norepinephrine. Then we have the negative chronotropic. Negative is things that are going to slow the heart rate. This would be acetylcholine from your parasympathetic and the vagus nerve. This would also be things that block norepinephrine. So remember, it's like taking away the gas pedal. That would be your beta blockers and your calcium channel blockers. Electrolyte imbalance can also slow your heart. Now if we go look at stroke volume, which is how forceful the muscles contract. Stroke volume is affected by afterload. If the arteries refuse to receive the blood, you can't pump as much in there. Stroke volume is affected by venous return. So remember, this is when you become active, your muscles squeeze your veins and force that blood back to the heart. So increased venous return, your veins are returning more blood into the heart because of the muscles squeezing the veins. And then with increased venous return, you also get Frank-Starling law, where because of the extra blood being put into the heart stretches, so it contracts back with more force. Then we have our inotropic agents. So this is like the chronotropic agents, but chron, remember, means time. That acts on heart rate. Inotropic acts on the muscle. And just like the chronotropic, we have positive and negative. So positive, again, is going to be norepinephrine. Remember, the sympathetic nerves branch to both the nodes and the ventricles. So norepinephrine affects both rate and force. This is also going to be your things that enhance norepinephrine. So the thyroid hormone, the caffeine, the nicotine, and cocaine, same list as before. Also on this list, we have digoxin. Remember, that's the drug that's used to treat a weak heart because it traps calcium inside. For negative inotropic, we are not going to put acetylcholine. Remember, the vagus nerve does not branch to the ventricles. So we're going to have here just the things that block norepinephrine. So again, taking away the gas pedal. So things such as your beta blockers, your calcium channel blockers, and also electrolyte imbalance. Electrolyte imbalance does not block norepinephrine. It's its own thing that can affect the force of the heart. So there's a summary of your previous notes kind of put together in an organized way.